Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is normal thrust in arches. So, as per what we understand about the various arcs, those are parabolic arch, circular arch. Based on the hinges, we have 2-hinged arches, 3-hinged arches. So, in that, what kind of these normal thrust plays a role in arches? This is nothing but a horizontal component of the reaction force. It is nothing but the horizontal component of a reaction force exerted by the arch at its supports. So whenever the supports are there in this particular arch, we are talking about the horizontal component of reactions. That is nothing but the normal thrust. So in these arches, those are any structural element, they are going to transfer their loads primarily through compression, and in this compression force has both vertical and horizontal component at the base. So the horizontal component of this force is known as the normal thrust. So whenever in arches, this normal thrust is significant because it ensures that the arch remains stable and also it supports the applied loads without collapsing. So whenever we are using different types of loading condition as per the construction requirement and also the design parameters, based on the design parameters of the particular arch, whether it is maybe parabolic arch, circular arch, in this also we have different types depending upon the supports, how many number of hinges are there. There may be 2-hinged arches, 3-hinged arches, whatever it may be. In this, whenever we are applying various kinds of loads, those are concentrated loads, uniformly distributed load, point loads, and also the variation may be there in the throughout complete arch. So in this, they are going to support applied loads without collapsing. So for this, this is the significance involved for understanding about this normal thrust. So how the reactions are important, horizontal component point of view, for better understanding about the arches at the time of their analysis and also the design part also, this normal thrust plays a role. So in this, the design of an arch needs to account for this thrust to prevent supports from spreading to outward. So why this understanding is required? So once we design an arch, so whenever these, because of the loads, how it reacts, and also these kind of the terminology, this normal thrust especially is going to prevent these supports from spreading outward. So the amount of normal thrust depending upon the various several factors, those are shape of the arch. It depends upon the shape, whether it is semicircular, parabolic, circular, elliptical, whatever it may be. So this is the one of the parameter which we are going to understand in the, this depends upon the shape of the arch and also the how much span. Whenever we are using these arches for the longer span only, even though how much the length of the span and height of the arch and the magnitude of the applied loads. So what types of loads we are applying, so their magnitude is also plays a role in this normal thrust. The distribution of the loads, how we are distributing, the way of distribution of loads also. The way of distribution of loads also play a role in this normal thrust. So for understanding this, the amount of normal thrust, these are all the various parameters which are involved. in this normal thrust for a parabolic arch or a circular arch. So whatever it may be, the normal thrust at any point can be calculated using the static and the principle of the statics and equilibrium conditions. So according to that, we are going to understand what are the forces involved because of the load conditions, and also the how they are going to resist because of the shape or dimensions of that particular arch and their various parameters. So here in this we can find out as a part of reactions at the supports often through these methods such as equilibrium of forces. So resolving horizontal and vertical components, this is the one of the method which we choose for finding the normal thrust for the given conditions of the arch, and also influence for moving loads, and polygons for graphical methods. These are the various types which we choose for identifying find out what type of normal thrust it is. In practical engineering, normal thrust is important for designing the abutments and also ensuring that they can resist the horizontal forces produced by the arch. So finally, what we understand, this normal thrust is nothing but it is the resistance of the horizontal forces what they are coming from the existing loads of the arch. So for causing these horizontal forces by existing forces, it is going to reduce such terminology is nothing but the normal thrust. So here we have some key characteristics involved in this normal thrust. Those are direction. It always acts perpendicular to the arch's curved axis. So here this is the curved portion. This is going to act along the direction whether it is perpendicular to this curved axis. So and also this effect, it can cause either compression or tension in the arch's material depending on its direction, and also its magnitudes plays a key role in this normal thrust in arches. Whether it depends upon the type of arch, whether it is not depending on any type of arch, we may understand these characteristics. So this normal thrust only depending parameters are size and shape and loading conditions. These are the major parameters which we are going to influence this normal thrust in the arches. These are the two key characteristics we may understand in normal thrust. Those are direction and also the effect. In this normal thrust, the normal thrust is finally in single sentence. What we know about this normal thrust is resultant force that acts along the tangent of the arch's central line. Already we understood this normal thrust is wherever the parabola, whether it is this, like this, whatever its type. So based on this parabola perpendicular to this axis, that parabolic angle axis perpendicular to that axis, we will get this normal thrust. So according to that, the normal thrust is the resultant force that acts along the tangent of the arch's central line. So this is the single sentence understood about this normal thrust. Here we have variations. It is depends upon the magnitude of the normal thrust varies along its length, arch's length. How the magnitude is variation, the variations we will get from the depends upon the span length of the arch. So the length of the arch between the two supports. So like this we are on. It is typically highest at the supports and lowest at the crown. So the normal thrust because of this is nothing but the horizontal component. This is involved in this horizontal component. That's why That's why it is highest at the arch supports. Whenever the supports are there, it is there. At crown, it is lowest. So at the highest point of the arch, crown is nothing but, we know that is nothing but the highest point of the arch. Moving to the equilibrium, in a stable arch, the normal thrust at any point must be balanced by the horizontal and vertical components of the forces acting on the arch at that point. So it is nothing but the equilibrium is nothing but the whenever the stable arch, this normal thrust at any point must be balanced by both components, those are horizontal as well as the vertical of forces acting of the arch at that point. So here, what are the factors affecting this normal thrust in arches? Arch geometry. The first thing, the geometry, that is the shape of the arch, whether it is circular, parabolic or pointed, whatever it may be, it depends upon the shape, and also the load conditions. What type of load, whether it is point load, locational loads, it may be concentrated load. So different load conditions, those are maybe point load or uniformly distributed loads, uniformly varying loads, point loads, and location in particular location. So there is such type of different kinds of loads conditions are there. That is one more parameter which is influence this normal thrust of the arches. So the type and magnitude and location of the loads on the arch influence the normal thrust. And one more affecting factor, that is material properties. What kind of material is built by? So the arch is built by what type of material we are choosing, whether they are steel or concrete, what kind of arches they are. So on which material we choose for the construction of the particular arch, for analyzing or designing, this is also plays a role affecting parameter for this normal thrust. So the strength and stiffness of the arch material determines its ability to resist the normal thrust, and also the boundary conditions. So what type of support, whether it is 2-hinged arch, whether it is 3-hinged arch or fixed arch, the supports, what types of supports is also plays a role for that is also influence this normal thrust of the arches. So this boundary condition, the support conditions at the ends of the arch, example fixed, hinged, affects the distribution of the normal thrust. These are the various factors which are involved for understanding this normal thrust and also influence the normal thrust parameter. All these parameters, they are going to include the affecting the normal thrust. So shape, load conditions, what type of material we are using for the construction of the arch, already used for analyzing, already used for designing, what type we are choosing, these are all the parameters, and also the supports, what type of supports we are providing for those arches. These are the affecting factors, the normal thrust. Why it is important in design? So in this, it is nothing but the horizontal components. So the horizontal reactions, according to that, then only we are going to design the stability and also efficiency of the arch, and also the load bearing capacity are there. So in this, we are ensuring the normal thrust remains compressive throughout the arch is essentially for its stability. So tension can lead to structural failure. So that's why the normal thrust, for understanding the normal thrust plays a crucial role in arch design. So for understanding this stability. So once the tension is there in this compressive structure, so that lead to the structural failures. And move on to the efficiency. The distribution of the normal thrust can be optimized to minimize material usage and maximize the efficiency. So usage of the material. So we may change different types of materials. They may minimizing the material usage and also maximizing the efficiency for understanding this normal thrust. In load bearing capacity, the ability of an arch to carry loads depends on its ability to resist normal thrust. The ability of an arch to carry the various kinds of load conditions are there in this point load and also the various concentrated loads and uniformly distributed load. Throughout the uniformly distributed, or sometimes the load distribution is from some side, or uniformly varying load, it is going to vary uniformly. So these types of different scenarios we are understanding from this parabolic arch. So here the load, the ability of this carrying load, what kind of various loads, heavy loads in arch, it's in most of the cases we are used for the heavy structures, those kind of nothing. For example, bridges, we are choose these type of arch designs. So here they are carrying the structural loads, heavy structural loads. That's why this ability to withstand and the ability to the particular arch is to carry those heavy loads. So it depends upon the ability to resist the normal thrust. So that's why for understanding this normal thrust is the important parameter. And the shape and proportions of arch are often influenced by the desired distribution of a normal thrust. These are the parameters which we are going to understand. Examples of normal thrust in arches. So in stone arches, in traditional stone arches, the normal thrust is primarily compressive, ensuring stability. In steel arches, modern steel arches can be designed to experience both compressive and tensile forces depending on the load, and its shape and size is there for understanding these steel arches. In cable stayed bridges, these structures utilize a combination of arches and cables to distribute normal thrust and tension efficiently. These are the some of the examples. In the formulas what they are involved in normal thrust and radial shear in arches, the normal thrust is nothing but N, we denoted with notation that is equal to N is equal to H cos theta plus V sin theta. Here H is nothing but the horizontal thrust, N is nothing but the normal thrust, V is the vertical shear. So in these formulas we are understanding. So the radial shear we will see in our next classes, but that formula radial shear is equal to R is equal to V cos theta minus H sin theta. This normal thrust N is nothing but the normal thrust, that notation is N. N is equal to H cos theta plus V sin theta. The normal thrust is the resultant force acts that's along the tangential to the arch's central line. And this radial shear is the resultant force that acts along the normal to the tangent of the arch of the center line. It is normal to the tangent line. So this normal thrust is the tangent of the arch central line. That is the difference between these normal thrust and radial shear. In our next class we will see about this radial shear. Now here, according to the numerical values, how we are understanding this normal thrust in various arch types. So here we consider this parabolic arch. So a parabolic arch of span 30 meters and rise 60 meters carries a uniform load of 20 kilonewton meter over its entire span. So here the parabolic arch span is 30 meters and the rise is nothing but 6 meters and a uniform load of 20 kilonewton per meter over its entire span. Assume the arch is hinged at both ends. It means it is two-hinged arch. Two-hinged parabolic arch. Two-hinged parabolic arch. So here we are going to understand what we are going to determine, that is the normal thrust at crown of the arch. This is the, like this we are going to understand our problem. So simply I am writing like this. So here we have the parabolic arch. So here two hinges, those two hinges, the span between these two hinges is 30 meters. From here to here, the highest point of the arch is nothing but the crown. From here to here, this is the 6 meters rise. And also this uniformly distributed load from here to here, total the uniformly distributed load is there, that is equal to 20 kilonewton per meter. So now at crown point, find out the normal thrust. So this is the given thing. Now first what we know about this normal thrust is nothing but the formula. We know the formula. Normal thrust is, we are going to find out the normal thrust. So for a parabolic arch subjected to uniform loading, so the horizontal thrust is H is equal to WL square by 8H. Here W is equal to unit weight, uniform load per unit weight, that is equal to 20 kilonewton per meter. L is equal to overall length of the span of the arch, that is equal to 30 meters. H is equal to rise 6 meters. Substituting those values this, so the finally that is gives the horizontal thrust. H is nothing but the horizontal thrust. H is nothing but the horizontal thrust. So here the normal thrust at the crown of the arch, the vertical reaction due to the uniform load is equal to the total load divided between the two supports. Because why we are considered like this? Because it is a symmetrical one, symmetrical arch, because load conditions is same throughout the arch, and here we have two hinges only at supports. It means it is a two hinged arch. So that's why the total load of the arch is equal to, that is equal to this 20 multiplied by 30, that is equal to total load. We may convert it into like a point load. So whenever the reaction at each support is equal to, so reaction at each support is equal to W by 2. So that is equal to 600 by 2, 300 kilonewton. So the normal thrust at crown is equal to the horizontal thrust at crown, because there is no vertical component of the arch at the crown. So this is the normal thrust formula. N is equal to H cos theta plus V sin theta. So that theta is equal to 0 here. That's why we know the N is equal to H. So that is equal to 375 kilonewtons. Here, whenever the normal thrust at crown is equal to the horizontal thrust at crown, because there is no vertical component of the arch axis at the crown because of the similarity in loading conditions also. Now move on to the another type of problem in three hinged arches. So a three hinged parabolic arch we are consider, that is equal to three hinged, two hinges at support, third hinge at the crown. So from here to here, that is equal to 10 meters, from here 10 meters total. The span between these two is equal to 20 meters. The rise from here at crown to the support points at base points, that is equal to 5 meters. It is subjected to uniformly distributed load throughout the arch, that is equal to from total the uniformly distributed load, that is equal to 30 kilonewton per meter over the entire span determine the normal thrust at a point 5 meters from the left support. From 5 meters span. So between here to here, similar 5 meters. 5 meters from here, find out the normal thrust value from left support. This is the given data. This what normal thrust at this point we are going to find out. From here, determine the reactions at the support. So first we are going to find out the reactions at the support. Total load of the arch. Total load is equal to, so throughout entire the uniformly distributed load, that is equal to 30 into entire span is equal to 20 meters. It means 600 kilonewtons. Total load is equal to 600 kilonewtons. Since it is a symmetric arch like previous one, it is also a symmetric arch. Symmetric arch because of the load conditions are similar. At midpoint everything is similar. From here to here the load is there. Uniformly distributed load is entire span. That's why it is symmetrical arch. Since it is a symmetrical arch and 3-hinged structure, so the vertical supports at A and B. Consider these two are A and B and crown at C. Point C. So here find vertical reactions at supports, those two are equal. So reactions RA is equal to RB is equal to W by 2, that is equal to total load 600. So finally 300 kilonewton. So here the vertical reactions are, these are the reactions RA at support A, vertical reaction RB, that is equal to, so total load 600, this is equal to 300 kilonewtons. RA is equal to 300 kilonewtons, RB is equal to 300 kilonewtons because of the similarity of the arch. So here now find out the moment at the crown. So here now the next step we are doing, that is the find out the moment at the crown. For a 3-hinged arch, the moment at crown is 0. The similar condition, what is happened for 2-hinged arch, the moment at the crown is not equal to 0. Whenever nothing is there, there is no point there. So that's why it is there something. But coming to the 3-hinged arch, the crown at support is there for at point C. That's why the moment is 0. So the moment at any point or any other point can be found using statics and geometry. But for this problem, the focus is on normal thrust. So generally in 3-hinged arches, those are statically determinate structures. But here we require the normal thrust. So the equation for the normal thrust at N thrust X from the left support, that is equal to NH by cos theta. This is the thing we are choose. So now we have to find out this horizontal thrust. H is the horizontal thrust and theta angle made at that particular point, angle of the arch. At the point where the point of interest is there, the theta of the relative normal thrust theta we are going to find out. So here at 5 meters distance from the left, here we are going to find out the theta. So horizontal thrust and angle of the arch at that point we have to find out. Now H is equal to, so what is there for this is equal to H into 4 into rise is equal to RA into span. Now find out this H is equal to H is equal to 300 into 20 divided by 4 into 5. Finally that is equal to 300 kilonewton. So the geometry at arch at 5 meters. So it is a parabolic arch. That's why y is equal to 4h by L square Lx minus x square. We know this formula for parabolic arch. So h is equal to rise and L is equal to overall span length. X is equal to where we require this normal thrust. From left side here 5 meters. So apply and substitute those values. Finally we will get y is equal to 1.325 meters. Now cos theta, find cos theta. The slope of the arch at any point is equal to dy by dx is equal to 8h by L square into L minus 2x. So, or otherwise determine this equation with respect to, differentiate this equation with respect to x. Differentiate the equation, the arch, whenever the parabolic arch equation we are going to differentiate with respect to x. That gives the this one. So substitute all the parameters, we will get the angle theta tan theta is equal to dy by dx. So find out the cos theta value from this, that is equal to 0.196. Substitute all the values in n is equal to 300 by, formula is there, that is equal to n is equal to h by cos theta. So here substitute the value n is equal to h by cos theta. We know h horizontal thrust, cos theta values, that is nothing but the 0.196. So nearly it is equal to 1350.6 kilonewtons is the normal thrust value. Like this we are going to find out the various normal thrust. And one more normal thrust in two hinged circular arch. Here two hinged circular arch, there is no crown have any support, two hinged arches, and the overall span is 30 meters. The rise is from here to here, that is equal to 10 meters. And this 10 meters and is subjected to a point load at crown. At crown, the point load is there, that is equal to 100 kilonewtons. That is equal to, at point load, that is equal to 100 kilonewtons at the crown. Calculate the normal thrust at crown. This is the given data for this problem for two hinged arch. Two hinged arch is a statically indeterminate structure. So here determine this point load at the crown, find out the vertical reaction. This is A, this is B. So find out the vertical reactions, that is equal to RA. It is also a symmetrical one. Symmetrical arch. This is also a symmetrical arch. So find out the reactions. We will get the 50 kilonewtons. So horizontal thrust, we have to find out this horizontal thrust, WL square by 8H or PL square by 8H. We know the total load, that is equal to 100 kilonewton, and length 30 meters, rise rise is 10 meters. So substitute all the values, we will get the horizontal thrust. So find out, so at this condition we know normal thrust is equal to the horizontal thrust. Like this we are going to find out the various problems for normal arch. So in different scenario, one more numerical values and the uniformly distributed load, and determine the 6 meters from the left. So this is also similar like previous, but the load condition is different. Here two hinged arch, it is also two hinged arch. Two hinged arch. So the uniformly distributed entire span, uniformly distributed load, entire span is equal to 20 kilonewton per meter, and also the rise is 24 meters. Span of the arch is equal to, the span of the arch is 24, rise is 66 meters, span of the arch is equal to 24 meters. Find out the, determine the normal thrust at the quarter span. So middle, that is 12. From here they are asking this normal thrust. From here they are find out the normal thrust value. So from here to here, that is equal to 6 meters. Now from similarly find out the vertical reactions. RA is equal to RB, and this is the total load, overall entire span divided by 2, that is equal to 240 kilonewton, and find out the horizontal thrust, that is 240 kilonewtons, Find out the normal thrust. For this, first we have to find out the slope of the parabolic arch. That is nothing but the tan theta. From that, we are find out the cos theta. Substitute this formula, horizontal thrust, and finally we will get the answer. Like this, we are going to understand this normal thrust. So these are the some of the web references for helping this concept. We will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.